Introducing the rough terrain, small scale, remote control, utility vehicle. The M2-Pelican-X.
All right, let's talk about the mechanical systems. Here's a video at the Oshawa Tank Museum. Take it away, Eric.
All right, so as you can see, some utility vehicles employ using actual wheels. Now, for our utility vehicle, I feel like that's going to hamper the mobility and the variety of tasks you can perform. So for that case, we're not going to do this system. We're going to go with Caterpillar tracks. And if you come on over here, I will show you on this tank over here what I'm thinking for the design. Here we have a Caterpillar track with the various components such as the pins and the track shoe assembly, which is what I'm going to be mimicking with my utility vehicle. And we have here various amounts of wheels that are on torsion spring suspension. Now I'll be opting to have this up a little bit higher and have this profile down a bit lower and doing a torsion bar type of suspension, but it's pretty much similar. And as you can tell here, some of them have additional shock absorption here, and that will be needed. So for mine, on all of the wheels, I'm going to have these installed, one onto another so that each one shares its weight and load. And we have the guided wheels here, and on this end is the drive wheel. And I'll be basically following the same type of method here. So as you can see here, the drive wheel interlocks into the pins of the track assembly, and this is where the power is partly transferred. And there's also around the other side, there is more of another set that also grabs on and pushes, and there's a guide section here. So this will be kind of similar to what I'm going to be doing, where I'll be powering the drive wheel and pulling the track along on the ends here. I might opt to do something where I'm grabbing it in the middle if I feel that with the fabrication methods and prototyping methods, this might not be strong enough for a smaller scale. So it might be important to find some different way to drive it if this doesn't work. But I will tell that by prototyping, testing the design, and seeing how that would work.
Yeah.
Beautiful.
So you'll have to excuse my nomenclature there. I made some notes here that I meant the drive sprocket, the return rollers, and the pneumatic shock absorber. One note, as you saw, there was some damage on the shoes there. So depending on the shoe, there tends to be damage. So I'm going to opt for the M1A1 Abrams style T158 shoe. It's less wear, but I'd like to go for a shoe track because I would like to reduce the vibration and damage to floor surfaces when I'll be eventually taking it indoors and on the road. Next, the pneumatic shock absorber is not going to use any type of hydraulic fluid. I'm just going to use air, compressed air, and I'll have them interconnected. On that tank there, they were connected to the hull, but this time I'm going to have them connected to each other and have that dampening effect. Yeah, so that's pretty much it for the mechanical systems. And now we have our electrical systems. Let's first start with talking about batteries. So the choice was between a lithium FePO4 battery or an NMC. The PO4 has better cycles up to 5,000, and it also is less expensive. It's not prone to overheating or exploding, if you want to be safe. It does have 150 watt hours per gram, which is a little bit less than the 200 of the NMC, but for our purposes, I think this is a very good battery choice. Next, we have galvanized circuits, which means isolating them from noise in the different various parts of the circuits. This will be done with relays, transformers, and flybuck converters, which use rapid MOSFET switching and capacitors to smooth that out. The reason we don't want this is because when we have inrush current and when we have back EMF from the motors and various currents under load, we don't want this causing our microcontrollers to get false readings and have issues there. Next, it's going to be the slip ring. This solves entangling wires by allowing the wires to be able to rotate 360 degrees without being caught, so you could turn indefinitely the device. Slip ring is defined as an electromechanical device that transmits electrical signals from a stationary structure to a rotating structure. So certain attachments might want to continue rotating freely, indefinitely, and this fixes that issue. Next, we have communications. So the device is going to use a Wi-Fi to transmit processed video signals and information that's been done through processing of those videos, such as getting distances and determining what objects are and elevation and different terrain information. Things that won't be necessarily for steering the vehicle, but additional information to help assess when the operator is using the vehicle. Next, we're using LoRa transmission to get a much more extended range from our vehicle. This will be exclusively used for controlling the utility vehicle itself, the motors, and all those low-level critical systems. There is some issues with this, that the data transmission is low and the transmission rates have to be in a certain amount during each hour due to Canadian federal regulations on communications. And the megahertz for this has to be within a range. I've chosen 915 megahertz, and that's suitable. Next, we have the FPV, first person view, using 5.8 gigahertz for extended range. This one also has a high bandwidth, so we can transmit just a video signal of a single stationary camera, probably on the rotating structure of the attachment. And more than likely, when that attachment is not used, it will rely on the Wi-Fi in the other cameras. So we'll see about that in the prototyping stage. All right, next we have microcontrollers. So there was two choices. I had the choice between using Tinsy 4.1 and Arduino, and I chose the Excuse me, do you mind? Can you? Sorry about that. Anyways, I chose the Tinsy because it is 600 megahertz instead of a much lower amount in the Arduinos. It has 8 megabytes of flash memory, 55 pins, similar to the Arduino, and it also has Ethernet capability for talking for the Raspberry Pi. This will be used to control the motors and other various sensors and low-level components. Next, I have the Raspberry Pi, which is used for imaging process, as I had said before, using artificial intelligence, detecting images and such. It has Wi-Fi also, so it'll be able to collect information from 3 or 4 different cameras and to process that information and send it to near-range computers that are set up with it. Anyways, it has also 8 gigabytes of RAM for better processing, so it was a clear choice to use the Pi and 8 gigabytes for this heavy processing of images. Next. All right, so let's talk about the experimental setup and some of the tools I'll be using. First will be the X1C carbon 3D printer, additive manufacturing. I will be using PLA, ASA for outdoors, ABS for some higher temperature and a bit more strength, PET carbon fiber, a bit more brittle, but it could be good for some key structural components, and PETG, I think I maybe mentioned, but other materials like that. And after I get things prototyped and make sure they're fitting, I will assess which parts would be good to be machined in the subtractive processing with a lathe and a mill. Next, I have a DC power supply, an oscilloscope, and a function generator. I have these 3 models. I will be using them to be testing the circuits and the motors and all the pulse width modulations and different signals that I'll be using. Next, we have the stepper. I'll be using steppers for controlling the tank, I think. It will be dependent on all my component selection and weights and seeing how much torque I need and holding torque, and I'll just assess from there. Next, we have obviously some bench tools, a computer, some more whatever that thing is. Oh yeah, can do some welding. That sounds exciting. And some electrical components, my favorite. So yeah, that pretty much is it. Obviously, I have a lot more various tools I won't get into because, yeah. But anyways, and that concludes our video. Is there any questions?